For example 6, we're looking at some houses to buy, and we need to find a 30-year mortgage. So far, you find the following deals. Mortgage A, B, C, and D are all listed with some interest rates, and then also these are compounded differently. So for part A, we need to decide which mortgage will cost you the least over 30 years. What I'll do on the right-hand side here is I'll go ahead and write the formulas out, and then we can compare those and write that answer down here on the left-hand lower side. Mortgage A is 5.5% compounded annually. Now, this wouldn't happen in real life, but if you didn't make any payments and at the end of 30 years they still haven't taken your house, of course that won't be the case. Well, let's just imagine that that's what's going on. We can investigate each one of these just using our normal formula. A is equal to P times 1 plus R over N, our compounding interest formula, to the NT power. 5.5% compounded annually, N is 1. So we can use our formula. A will be P, and P, let's make 300,000. You can see here we're going to need to use 300,000, so let's go ahead and make it 300,000. It could be really anything, it just has to be the same thing for all these, and if it's the same value, the same initial value, then we'll be able to compare and see how we're doing after 30 years. And this will be 1 plus 0.055, that's the rate, 5.5%. N is 1, and this will be 1 times 30. We can just type this in to our calculator, and let's see what we got here. 300,000 times 1 plus 0.055, and that's going to be raised to the 30th power. We'll hit enter. So this would be 1,495,185 and 39 cents. So that's $1,495,185 dollars and 39 cents. Now that again would be if you did not make any payments. Also, you can think about this instead of being a mortgage as maybe being a savings account. Maybe you have your money in the stock market, or perhaps some bonds or some other investment vehicles. And if you're earning an interest rate of 5.5%, if you start off with 300,000 in 30 years, you'll have that amount, which is a lot nicer than just 300,000. So if you let that sit under your pillow at home, and you compare that to what will happen if you do invest it and get 5.5%. Compounded annually, which is it's a decent rate, not too good but not too bad either. You'll have that in 30 years, a nice chunk of change. Let's move on to part B, and part B here is 5.4%, so the rate's a little lower, and this one's compounded quarterly. So how many quarters are there in a year? Well, there's 4 of them. If we go straight to our formula here, A is equal to, we're using 300,000. This is just arbitrary. I know we're going to have to use it later, so that's kind of why we're using it. But 300,000 just needs to stay the same between all of them. And this one's going to be 1 plus, and then we're going to have 0.054 divided by 4. And that's going to be raised to the 4, remember N, times T, which is 30 power. So let's go ahead and type that into the calculator. We've got 300,000 times 1 plus 0.054, and that needs to be divided by 4. And then raise, in this case I don't need to use parentheses because I have a nice program in this calculator, but for those of you that don't, if you just have the little caret, the little hat symbol right here, you need to go ahead and use parentheses, and this is going to be 4 times 30, or I mean, you know, if you do that in your head you can make it 120, that's fine too. So if we hit enter here, we have this whole thing being equal to 1,499,586 and 83 cents. So if we compare the first two together, looks like, even though the rate is lower, it's being compounded more often, and so therefore will cost a little more in this case. So what people in the banking and financial industry and mortgage industry do is they kind of play around with these, and see which one you're going to bite on. And actually, if you say, ooh, the rate is lower, I'll get that one, they are making out because it's going to cost you more money in the long run. So be very careful. Make sure that you know what you're doing and that you're finding the actual values of these loans that you're going to get, whatever it is, and also your investments. Make sure that you're paying attention to the compounding periods and then also the rate. Let's try Mortgage C here. Mortgage C is compounded monthly. Well, there's 12 months in 1 year. So to write our formula out, we've got A is equal to, we'll separate these off. A is equal to 300,000 times 1 plus 0.053 divided by n, which is 12, and then 12 times 30 will be in the exponent position. So let's see what happens here to this one. And we're just going to type that right back into the calculator. So we've got 300,000, and then it's going to be times 1 plus 0.053 divided by 12, and then all raised to the 12 times 30 power. And we're going to hit enter, and we've got our loan amount here, 1,465,983 and 36, in this case 36 cents. I hope you can see that on the right hand side of the screen. So if we're looking at these three right now, we've got a middle of the road, pretty expensive and not too bad. So this one, the rate helped us out much more than it did with these two. Compounded continuously. Continuously means we need to use a different formula. That's going to be A is equal to the PERT, or P times E to the RT power. So if we use that formula here, our initial amount still is 300,000. E to the rate, which is 0.0529 times 30 power. So let's figure out what A is going to be in this case. And we can just type this right in again. 300,000 times E. Remember to use your E button. Don't use a rounded value. We're going to raise that to the 0.0529 times 30 power. See what happens. So this one is going to be 1,466,717. Oops, that's a 7. And then 0.92 will be the cents there. So we'll make that a 717. Maybe you can see that a little bit better. So 1,466,717.92. This says decide which mortgage will cost you the least. So 1.495, 1.499, or 1499, there's no decimal there, 1.465, and 1.466. So it's this one. So Mortgage C, if you were picking and choosing between these, which you're going to have a lot of options when you get to that stage of your life, maybe you already have a mortgage, so this one is going to be the best option. Part B says if you get the mortgage for 300,000, great, we've used that value. Compare your cost savings between the most and least expensive loans. Let's take a look at the most expensive. 1,495, 1,499, 465, and 466. It's this one right here. So it's 1,499, 586 and 83 cents, and that's B. We're going to have to subtract the least expensive, which we said was Mortgage C. So Mortgage C is 1,465,983.36. So that was C. So this was our most, and this was our least expensive. And we'll just use our calculator to type that in. 1,499,586.83 minus 1,465,983 and 36. And you can see that we end up here with 3,363 and 47 cents. So the amount that we've saved is quite a decent chunk of money. I don't know about you, but I could think of a number of things to do with a little over 30 grand. So it doesn't really matter if this is a mortgage situation or a loan situation or an investment account situation. You do want to take into account all of your compounding periods and interest rates, and then do a little bit of math and figure out which one's going to be better. And if you can do a little bit of math, sometimes you can really give yourself a good bump at the very end, or in this case, we're dealing with mortgages, save yourself a good chunk of money.